Hello friends, last lecture we discussed on the nuclear reactions. In that we discussed about the introduction of the nuclear reactions, types of nuclear reactions and conservation laws. In types of nuclear reaction we discuss on scattering reaction, elastic, inelastic scattering, direct reaction, that is pickup reaction, and some other reactions like spontaneous nuclear reactions, compound nuclear reactions. Okay, now after that, we discuss on the conservation laws like conservation of mass, conservation of charge, conservation of energy, conservation of momentum. And the next article of this topic is the mass and energy conservation in nuclear reaction. Here we first discuss on the nuclear reaction. After that, we go to the one of the new parameters, the Q value. Okay. See friends, here, here small x small x is the projectile. This is the projectile. Remember that it is a very small one having mass mx. We are representing mass as a small mx. Okay, what is x? X is a projectile. When two bodies are interact with each other, where mx is the projectile which is bombarded on the target x. Target is x, and its mass is capital M x. Capital M x. Okay. And when the projectile is bombarded on the target, it reacts with the projectile and what form? Product nucleus. This is capital Y, and its mass is capital My. And addition to that, some particles are formed, that is the product particle, which is represented by small y, and its mass is small y. Product nucleus mass is capital M and represented as a capital Y. Okay, this is a very important one. Okay, so while we are going to the nuclear reaction, remember that in the nuclear reaction, what we are showing here, it can be represented like this. What is that? This x, small x represent projectile, capital X represent bombarding on the target. Generally target is steady. Okay, see this target, and when the projectile is interact with the target, it's after reaction we can get the product as well as product particle. This is the product nucleus and product particle. The reaction takes place like this one. Okay, two body nuclear reaction. Okay, and the angles we are not considering here because in this article we are just going to be just discuss on the Q value, and by the conservation law we are considering that net mass and energy is conserved in this nuclear reaction, and according to that, for this projectile, for the projectile, it has kinetic energy Ex plus mx c square, energy mass relation, just like E is equal to mc square. We know that E is equal to mc square, and according to that, if mx is the projectile, its mass is mx, then we can consider that Ex as a mx c square plus what is the capital Ex? It is the kinetic energy. Okay, but target was steady, and therefore here the term is absent, that is the Ex means which term is absent here? E capital X is absent. Why? Because target was steady and only the mass energy represented as the mx c square. This is the left side. Up to this is we are considering here the energy relation, and remaining part here, that is the product nucleus and product particle. And Both are in motion, therefore it has the kinetic energy Ey. Mass energy relation is my c square for the product nucleus, and for product particle we can consider that Ey plus small my c square. Okay, these are the just equation where mx, my, mx, small mx, capital mx, and capital My and small my are the masses of projectile particle, target nucleus, product nucleus, and product particle. Okay, all E's are representing the kinetic energy. The E's are representing the kinetic energy, which C, these, and these three Ex, Ey are the kinetic energy. See, in this reaction, we define first what is Q. We define here. That is the net change in kinetic energy. Net change in the kinetic energy, or change in the net kinetic energy. How we can define that net change? We are considering the kinetic energy of the product minus kinetic energy of the reactant or the initial particle, and therefore we can write this Ey plus Ey, capital Ey plus small ey minus Ex. Now, if we are go to the earlier article and we are using this value of Q, in earlier equation can be represented like this one. Means we are changing the Ex to the right side and mx, my and small my to the left side. Then our equation become like this. And on the basis of that, we define here Q is equal to, it is nothing but the Q is called as the energy balance of the reaction, or Q value of the reaction. Generally in every nuclear reaction, the value can be represented in terms of Q. The Q value of the reaction. The value of Q is positive. If value of the Q means the subtraction is positive, then we call it as the exo energy. We call it as the exo energy. And on the basis of that, we define here when we require the energy, when the energy involved, or you can say that the exothermic reaction, the heat is involved, or sometimes the energy heat energy is emitted, or high temperature emitted. In that case, we can consider that Q is the positive, means mass of the product is less than the mass of the product is greater than the, or less than the mass of the reaction, or you can say that the reactants. When Q is positive, then this term must be positive, and means this term will be less than this term. It means kinetic energy of the product is less than the kinetic energy of reactants for Q is positive. If Q is negative, for negative terms, these two terms should be less than these two terms, because these are the negative one. At that case, what happens if we are considering that the kinetic energy of the product is greater than the kinetic energy of the reactants, then definitely you can say that Q is negative, and this type of reaction is called endo energy. Endothermic means it requires the energy. We want to supply the energy. Okay. In this case, we want to supply the energy to conduct the reaction. This type of reaction is called as the endoenergic or endothermic. Okay. For exoenergic, energy is emitted. It heat energy is involved. You can say that the heat energy is emitted, like that one. But here endothermic, the heat energy is absorbed, heat energy is required. Okay, the reaction required the heat energy. Okay, and the energy minus Q is required to excite the compound nucleus, and that energy is called as the threshold energy. Threshold energy means what? Minimum energy required to start the nuclear reaction. Generally what happens, some reactions are started with the external triggering, or we want to provide some energy, and that type of energy is called as the threshold energy. Okay, threshold energy means what? We require some energy to excite the compound nucleus to break, so that is the threshold energy. Okay, the next we are consider that